In this lesson, we will learn about Azure Virtual Network or Azure VNET. First, we will find out why we need Azure VNETs. Then we learn about Azure VNETs, subnets, and the reserved addresses in an Azure subnet. After that, we will create a new Azure VNet and its subnets. And finally, we will conclude our lesson with the review questions. As we know, most Azure resources can be created without requiring a connection to a subnet of an Azure VNet. So why we need Azure VNet? Let's take a look at this example. In this example, we create an Azure Kubernetes service and an Azure SQL and an Azure storage account. To access an Azure SQL database from the Azure Kubernetes, the network traffic has to go to the Microsoft backbone network to the internet and go back down to the Microsoft backbone network and access the Azure SQL database via its public interface, which means the network traffic is not optimal. Moreover, when a server in our on-prem network needs to access a file in the Azure storage account, the network traffic has to go to the internal network and expose to the internet and get back to the Microsoft backbone network and access the file on the storage account via its public interface, which means the traffic is not secure. That is the reason why we need to create Azure VNets. With Azure VNet, it allows us to create private connectivities among our Azure resources, and it also allows us to create a private connection between our on-prem network and the Azure VNet. So what is Azure VNet? Azure VNet is a private network in an Azure location to allow Azure resources to securely communicate with each other and with the on-prem resources. Each VNet has a name and is assigned with one or more address spaces. These address spaces should not be overlapped with any address spaces within the network of the organization. An Azure VNet must be segmented into one or more subnets which provide the connectivity to Azure devices. A subnet has a name and is allocated with a single non-overlapped range of IP addresses within the VNet space and in the format of CIDR notation. By default, devices in different subnets can communicate with each other. For example, in this Azure VNet, we create a new subnet named vm-production-snet, and we assign an IP address range 10.0.0.0/24. As you can see, this address range is within the VNet space. Now we can create a new VM and connect it to the production subnet. Similarly, we can create a new subnet and name it VM depth subnet, and we assign the address range 10.0.1.0/24. As you can see, this address range assigned to the depth subnet is not overlapped with the address range assigned to the production subnet, and it's also within the VNet space. Now we can create a new VM and connect it to the dev subnet. And by default, the VM in the dev subnet can communicate with the VM in the production subnet without any restriction. To assign addresses correctly to devices in a subnet of an Azure VNet, we should know about reserved addresses. Now let's list all the reserved addresses of the VM production subnet. The very first address 10.0.0.0 is reserved because it is a network identifier. The second address 10.0.0.1 is reserved because it is the default gateway address. The third and the fourth addresses 10.0.0.2 and 10.0.0.3 are also reserved because they are the DNS IP addresses. And the last address 10.0.0.255 is also reserved because it is a network broadcast address. Let's create a new Azure VNet and its subnets. To do that, we first need to create a new resource group by clicking on Resource Groups. Then click Create. Here we type in the resource group name ITL-infra-RG for resource group, and 01 is the order number. Now we click Create, and that's it. As you can see, the resource group ITL-infra-RG01 has been created successfully. Now, to create a new VNet, in the search box, we type in VNet, then click on Virtual Networks, then click on Create. As you can see, it selects the correct resource group ITL-infra-RG01, so we keep it. Now in the virtual network name, we type in the name of the virtual network ITL-EUS-VNet01, and we keep the default region is US, then click Next. In the security, we keep the default option, so just click Next. Now in the IP addresses, as you can see, it plans to create the VNet with the address space 10.0.0.0/16, which is what we plan for, so we keep it. If we plan for a different address space, we can update it here. Now in the subnet, if we plan to create the VNet without a subnet, we can delete the default subnet and create the subnets later. However, in this case, we will create new subnets. As you can see, it plans to create a subnet with the name default and the address range 10.0.0.0/24, which is what we plan for. So all we need to do is to click Edit and update the names of the subnet to VM-prod-snet. So in the name, we update it and everything here looks good. So all we need to do is click on the Save button. Now we add the subnet for the development, and in the name we type in VM-dev-snet. As you can see, it selects the next address range 10.0.1.0/24. It looks good, so we just need to click on the Add button, then click Next. In the task, we keep the same, then click Next. It will run the validation, and when it's ready, the create button is available for us to click. So just click to create. That's it. This process takes a few minutes, then it will create a VNet with the two subnets that we enter. The virtual network ITL-EUS-VNet01 has been created successfully. Now let's click on the address space. As you can see, the VNet was created with the address space 10.0.0.0/16 that we entered, and we can add additional address spaces as we wish, and these address spaces will be used to assign to the subnets. Now let's click on the subnets. As you can see, the VNet was created with the two subnets vm-prod-snet and vm-dev-snet with the correct address ranges that we enter. Now let's click on the production subnet. Everything looks good. Let's conclude our lessons with the review questions.